it to your left. Take one, pass it to your left. I got you. Take one, pass it to your left. You should be flowing, finish flowing in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Raise your hand and stop. If you got missed and you need a package. Look, let me go. I got you. I know about things. I want you to make sure you got this right. All right, team. Stand on the back table. I'll give you a second. Tracking me in 3, tracking me in 2, tracking me in 1. Waiting on 1 in column 1. Sarah, thank you. Thank you, Amaya. I have all of column 2. Waiting on 1 in column 3. They ran. They run. You earned a deduction. Go ahead and sit up for me. Your eyes are on me. All right, team. We're starting a new unit today. Our unit we're being introduced to magnetic fields. Okay? When I say go, you're gonna have 5 silent and solo minutes to watch a video. While you're watching this video, you're gonna be answering question 1 and 2. What I want to see is you annotating question 1 and 2, and then answering the questions while you're watching the video. When I come around and see your annotations, that lets me know you've already read the question and that you understand the question. That way, when you hear the responses in the video, you're automatically writing them down. I'm going to repeat that. You're annotating the question. Shout out to Sarah, she's already started annotating. And then you're going to be answering the question as you watch the video, silent solo. Any questions? I want to play stuff.
The Universal Space Agency's Magnetic Launch Program hopes to one day use high-power magnets to send spacecraft to Earth's orbit. Traditional rocket launchers give off pollution and can only be used once, while magnetic launchers would be environmentally clean and reusable. Magnetic launchers are years from being ready, but the team at the Universal Space Agency has constructed a model magnetic launcher to begin testing the idea at a small scale. This team has made an exciting step towards a technology that could lower the cost of space travel and make it more widely available.
This video promoting our project was going to be released to the public today, but our latest round of tests was a disaster. Our small model needs to reach a launch speed of 100 meters per second, which is scaled up would be the perfect speed to enter Earth's orbit. But so far, we haven't gotten it to work.
We did an extension.
We did, but it's not long. Latoya, can we start with the report from the engineering team?
Sure, Taylor. So during our first test on Monday, the model spacecraft only reached 80 meters per second.
That's too slow.
Right.
What about Tuesday's test launch?
On Tuesday, we tried moving the magnets 1 centimeter closer together, which increased the launch speed to 90 meters per second, 10 meters per second faster. That was closer to our goal.
But not fast enough.
Correct. Finally, on Wednesday, we tried moving them another centimeter closer, and this is the strange part. We got 120 meters per second.
So instead of increasing by 10 meters per second like we did on Tuesday, we increased by 30 meters per second.
Exactly. We overshot our target speed of 100 meters per second, but we don't know why.
Okay, so we need to figure out why Wednesday's launch speed was 120 meters per second. The magnets were only 1 centimeter closer, but the speed jumped by 30 meters per second instead of just 10. Mateo, any thoughts from the physics team?
Yes.
I meant out loud.
Okay. I got it. So the issue is that by shortening the distance between the magnets for Wednesday's launch, we produced a bigger effect than expected. There are 2 possible explanations for this. 1, something caused more energy to be added to the system than expected for Wednesday's launch. Or 2, something caused the magnetic forces to become stronger than expected for Wednesday's launch. It's either one or the
Actually, I think I see a third possibility. Isn't it possible that there was no change to the energy or magnetic force? Maybe we just didn't line the magnets up correctly the first 2 times, and then on Wednesday, we finally lined them up correctly and got the faster launch speed.
Fire hazards comes to the paper, answering questions. Jeremiah gets his,
Okay, good meeting. We now officially have 3 options to investigate. Drop everything else. I want this to
Rashida
be
has
top
the
priority.
paper, answering questions.
Latoya, Mateo, your teams work together on this and keep me informed as to your progress.
Premier has his, comes to the paper,
Let's
answering
make
question
history.
number 2. Alright, that's the end of our video. You're checking me in 3, checking me in 2, checking me in 1. I have column 1's eyes, waiting on Virgil. I have column 2's eyes, column 3's eyes. When I say go, you're gonna turn and talk to your shoulder partner. Have you ever tried to make a paper clip move across the table? And if so, how? 1, stop with me, turn to talk. Think about magnetic.
Oh, you put it above it.
So you've done this experiment before?
So I turned around, I think like on the south, and I come going against it, and then I rotated it, buddy.
Clap, 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 clap. Clap, 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 clap. Alright, so I did hear 2 groups that I was, want to share out. We're gonna start over here with, Serenity and her shoulder partners, tracking Serenity. Go.
I said that I put the paper clip on the table, and then I put a small magnet on it, and I still moved it with the forces at the opening.
I see some people agreeing with you. 2 snaps for her, 1, 2. 2 snaps for her, 1, 2. Martez, what did you and Lakeisha say? Tracking Lakeisha and Martez over here to my left, your right.
Oh, so basically, the magnet, I had flipped it over, and you turn it a certain, when you turn it, I can't remember if it was north or south, but when you go against it, it'll start to back up. And then when you flip it over, it'll start to present.
Okay, 2 snaps for him, 1, 2. I'm sorry, I know you weren't through. 2 snaps for him, 1, 2. Alright, that was just a fun little conversation. I want you guys to engage with each other and to get you introduced to magnetics. Let's go ahead and break down our warm-up so we can move on to the sim. So, in question number 1, I can't never remember your name. So, by Michelle. Michelle, what did you put for number 1? How do you think the launcher can make the spacecraft move without touching it? What'd you put? You didn't get anything? I'm sorry. I thought I saw something.
I got something for first one.
Her shoulder partner had something.
Oh.
I'll get you on the second one, okay? What did you put?
Well, I think it's also, is there something there is something
Finish some shine.
magnetic to take that launcher?
Something magnetic
Yeah.
underneath or in the launcher that did what? Help her out. Anybody want to build on what she's saying? Martez, what are you gonna say?
So, I was gonna sit for number 2.
Oh, you want to answer number 2? Go ahead and help her build on number 1. Jeremiah.
Magnets go against that. I'd say, how do I go against each other? Like, push it up, rock it.
Does it have to push it? Let's think about energy.
I would say have to push it, but it's a kind of energy to like move the rocket.
Energy. Yes. So you have to have a powerful amount of energy in order for a magnetic force to be able to move an object. Go ahead and write that down if you don't have it written down already. Okay? A powerful magnetic force causes magnets to move. A powerful magnetic force causes magnets to move. Before we jump jumping to number 2. I want to take a deep dive into the diagram that's at the bottom of your paper. It's gonna give you back causes magnets to move. Without touching it. And this will take the place of number 2 because we have to move on. So in the video, it talks about Monday, Tuesday, and Wednesday. All eyes on me. All eyes on me. When I say all eyes on me, y'all say all eyes on you. All eyes on me.
All eyes on you.
All eyes on me.
All eyes on you.
All right. So Monday, the magnets were at 4 centimeters apart, going at how many meters per second? It's on the paper. 80. Then Tuesday, it was 3 centimeters apart, and it started going at how many meters per second? 90. And then Wednesday, it was going at 2 centimeters apart, going at what? What was the goal? 100 meters. So Wednesday, they surpassed their goal. Does anybody know what happened here that did not happen here? I want a different hand this time. Brandon, in the front. Loud and proud so your peers can hear you. No one, did y'all hear him in the back?
No.
I was standing right beside and I barely heard him. Try one more time, Brandon.
I said the magnetic force made it jump over.
He said the magnetic force. Here you go, baby. You can't make nobody move. Sit right here, sit right there, or sit right there. Okay? He said the magnetic force made it jump up in distance, in speed. One more. Jeremiah. Nobody can hear you, Jeremiah.
The magnet was pushed like a lot closer.
A lot closer? Does it look? Ooh,
I'd say like,
it was pushed a little closer.
it was pushed a little closer to the other magnet instead of being more speed.
Okay. That's a possibility as well. We don't know the right answer, but what Miss McCoy has is that they were aligned. Okay? Because sometimes if the magnets are not aligned with each other, they will have difficulty changing or pulling or repelling, pulling apart, or attracting each other. So sometimes you have to make sure that the North Pole, which is at the top, and the South Pole that is at the bottom, are aligned with each other. One last thing, and then we're gonna move on.
I had a question. And so, if it's not on course, like, wouldn't it flip?
I don't know. We're gonna look at the film and see if it's gonna flip in the film, okay? Meet me on page 2. When I say flip, you say flop, flip, fly, flip. Charisma has flipped her paper to page 2. Enrico has flipped his paper to, thank you for helping her, to page 2. Virgil is on page 2. Alright, team, we're gonna jump into this film really quickly. We have 3 to 7 to answer as Ms. McCoy models this film for you up here on the board. So your job is going to be to answer questions, be engaged, ask questions, and that's it. Alright. Bonnie's here. Read question number 3 for me. Loud and proud. Brandon.
What happens when you put the same
I'm sorry. It says what for number 3?
What happens when you put the same or 2 magnets together?
Alright, team, so let me tell you what's happening at the bottom of our legend down here. My toolbar is in the way, Ms. McCoy don't know how to move it. But what's going on right here, the first magnetic pole is has a weaker force, okay? The second one has a stronger force. This one that's really light, this is a piece of aluminum, okay? This third one here on the end is a piece of steel, and then the last one is a piece of wood. And so we're gonna try the simulation with all of the objects at the bottom and observe how they respond to the magnetic field. Serena has a question. No masses, all magnetic energy. We're in a different chapter or different unit. Alright, so it says, same pole. So I'm gonna drag this one up, and I'm gonna drag up the other pole that's just like it, side by side, and Ms. McCoy is gonna run. Kai, what's going on in this observation right here? Checking Kai. Who knows the two words when they go together or go apart? Mariah. Nope. Repel and what? Attract. So when they repel, they go what? Hold on 1 second, because I don't have 100% of my team tracking me. Now, this is a whole group assignment because Ms. McCoy thought it would be better if I model for you and you write versus everybody having computers. But I need 100% engagement and participation. Okay, so once again, repel means to do what? Move in opposite directions. Attract means to do what? Just what it says, attract. So what do these two same magnetic poles do?
They repel.
Okay, go ahead and write the answer to number 3 down. Silent and solo, 30 seconds, go.
Wait. What was the two words again?
That's what happens when you're not paying attention.
No, we're doing attraction so much.
Repel. Flip the page over, you'll see the words.
Same pole, you like north and north. Hey, what do you mean? You say the same pole like you would north. I think they call it pole.
Let's replay it so you can see it.
I know it.
Back in the board for 1 second. Martez asked a great question. Where it says same poles, that means that the poles are on the same at the top and same at the bottom. This is considered the north, and the bottom is considered the south. So when you put two poles together that are the same, what happens?
They repel.
That's what you should be writing in number 3. Use the complete copy sentences. We're gonna see in a minute. Right now, we're gonna stick with number 3. Okay. Moving on to number 4. Let's see what happens when you put the opposite poles together. So I'm gonna go back to Bill. And right here, I'm just gonna click and hit this little arrow, make it rotate. So now they're opposite poles. Let's watch and observe what happens. Go ahead and fill in the question on number 4. Brandon has his pencil to the paper. You need a pencil. Lakeisha, we're on the board level 0. You got about 10 more seconds. We're gonna move on to number 5. 5, 4, 3, 2, and 1. Number 5. Which metals react to these magnets? So I'm gonna go back to Bill. What do we got down here? What did I tell y'all these 2 were? Which one is this one? Who said that? Aluminum, okay? It is a type of metal. So we're gonna see, we're gonna delete this one. And we're gonna add the aluminum. I'm gonna hit run. What happened?
They don't attract.
You're gonna write on number 5 what happened with the aluminum. Leave room. I know, I still want you to write what happened with the aluminum. Do the best you can. Got about 10 seconds left. So you have to test out both y'all to see which one actually has a reaction. And now I'm gonna get the piece of steel. Thumbs up if you ready. Waiting on my two ladies in the back, thumbs up or thumbs down, thank you. Alright, hands down. Alright, pay attention. Ooh. I'm gonna replay it from a further distance. I want you to see, this is a piece of steel.
I bet you gotta go to the middle.
Or you can just say iron.
You're still.
Huh?
So you can't.
I know, I need to,